Hello again. I just wanted to show my progress on customizing the Pis to make them more portable during data collection experiments. My goal is to remove any dependency on network and SSH connections into the Pis, so the data collection process can be fully automated without the need to log in. I also just wanted to mention that the Dell 43 watt-hour battery that I mentioned in the previous video is able to power the Pi for more than a day on a single charge, which is nice. I've connected a push button and two LEDs here. This is Pi 165. 165 is the last octet in its IP address, and the TX means that this Pi is sending beacons. Please excuse the sloppy soldering job here. This is a ground bar. This push button is connected between GPIO3, which is pin 5 here, and the ground. GPIO3 is pulled high internally, by the way, and the Pi runs a shut key daemon that pulls this GPIO, and I have a shell script that gets executed to stop data collection and then shut the Pi down when the button is pressed. So I'll demonstrate that now. As you can see, all the LEDs have gone off and the Pi is shut down. I'm using this GPIO3 pin on purpose here, since it's being watched by firmware, so I can go back and start the Pi up again by pushing the same button. You can see this small green LED starting to blink here. That's an indicator. For SD card activity. So we know the Pi is doing something. And in a second, once it's finished booting up, these two LEDs will turn on. It should be done in a second. There we go. So now the Pi has booted up. This green LED marked APP lights up when the piPACT Python script starts. I've modified the Python code to include LED control and created a systemd service to run the script on boot right after the Bluetooth stack comes up. This large red LED, marked busy, blinks on application activity. The Pi is set up to send beacons for 1 second each, and then sleep for 1 second, and then send beacons again in a loop. This black stuff here is insulator resin, electric insulator resin. All the flying leads are soldered to the connector that plugs into the Pi's board connector here. Don't solder anything directly to the Pi. As far as electric schematics go, it's pretty straightforward. Both LEDs are wired between the GPIO pin and the ground with this current limiting resistor in series here. I've been told that 330 ohms is a good value, so I'm using 330 ohm resistors here. That's pretty much all I wanted to show. I hope this was helpful. Please let me know if you have any questions.